B2 Industries has found that on an average market, 40% of the population are fans of their music. Of those 40%, they have found that the fraction that actually purchase a ticket can be approximated by e raised to the negative 0.05p. What price maximizes profit in a market with a population of 200,000 people and variable cost per ticket purchased of 18.09, assuming that seating is unlimited? So we don't have a capacity constraint, so our venue can hold as many people as we need it to. Well, let's solve for quantity first. It's 40% times n, which is the population size, which in this case is 200,000 people, times the fraction of the population that actually purchased a ticket. So that can be rewritten as 80,000 times e raised to the negative 0.05p. We want to write profit in this form: price minus marginal cost times quantity. When we take the derivative of the profit function with respect to p, we're going to use the product rule, which says first times the derivative of second plus second times the derivative of first. So let's break that down, taking the first part first. P minus 18.09, just first, times the derivative of second, and that second thing is 80,000 e raised to the negative 0.05p. When we take the derivative of that, the coefficient on the variable in the exponent p comes down and is multiplied to the coefficient of the whole thing. So negative 0.05 is multiplied by 80,000, which we then rewrite e raised to the negative 0.05p. That's the derivative. Plus second times the derivative of first. So we just rewrite the second thing, 80,000 e raised to the negative 0.05p, and we take the derivative of the first thing, which is p minus 18.09. And the derivative of that is just 1, because the coefficient on p is just 1. So now we can distribute through and start to simplify. There's a lot of mess, so take your time here in the algebra. That's the trickiest part for a lot of people. Distributing through that negative 4,000 e raised to the 0.05p, we get negative 4,000 p times e raised to the negative 0.05p plus 72,360 e raised to the negative 0.05p plus 80,000 e raised to the negative 0.05p. So we can combine those two last terms. Looking at it again, we can combine them and get 152,360 e raised to the negative 0.05p. We can add 4,000 p times e raised to the negative 0.05p to each side. And now we can divide through by 4,000 e raised to the negative 0.05p. So first I just did the dividing through by e raised to the negative 0.05p to cancel those e's. So it makes it look a lot prettier. Now we can divide through by 4,000, and we find that our optimal price is equal to 38.09.